If you are still hiring human virtual assistants or running legacy background scripts to handle tasks like data entry, competitive price monitoring, invoice downloads, or multi-platform order fulfillment, you are working with an operational framework that is completely obsolete. The common consensus among most business operators is that artificial intelligence is fundamentally static, trapped inside a browser text box, dependent on clean API connections, or limited to reading text-based datasets. When people attempt web automation, they typically default to tools like Zapier or custom code libraries like Selenium. But anyone who has managed these setups knows the underlying nightmare. The moment a target website updates its user interface, alters a CSS class name, or moves a checkout button 3 pixels to the left, your entire automation matrix breaks instantly. You end up wasting hours constantly maintaining and rewriting code just to fix basic click actions. You're trapped in a brittle setup because traditional automation tools are completely blind. They don't see the web page, they just read the rigid code structure behind it. The paradigm shift occurs when you stop treating AI as a text generator and start leveraging it as a spatial agent. By combining the deep contextual planning of Claude with the open-source computer vision engine of Skyvern, you can deploy a virtual assistant that interacts with the internet exactly like a human being. It doesn't rely on hidden API configurations or fragile code selectors. It opens a visual browser window, views the page design through machine vision, and navigates complex, unmapped websites entirely on its own. To understand how a system can navigate the web without pre-programmed instructions, you have to look at the intersection of large language models and real-time computer vision. Skyvern serves as the interactive cockpit, while Claude provides the cognitive situational awareness. As detailed in the engineering model layout, the navigation stack operates via a highly dynamic, closed-loop process. The Vision Processing Node. Skyvern renders the live target web page and applies advanced object detection to draw explicit boundary boxes around every interactable element: buttons, text fields, drop-downs, and links. The Cognitive Planner. Claude ingests the visual matrix and the text objective. It analyzes the page state, determines the correct tactical step, for example, click the checkout button, and sends the exact mouse coordinate or keystroke back to the browser. The adaptive execution layer. The browser executes the physical mouse click or text input, waits for the new page state to stabilize, and immediately loops back to the vision node to assess the next action. Because the system relies on real-time visual analysis rather than hard-coded scripts, it doesn't care if a website changes its design or structure. If a layout updates, Claude simply scans the fresh visual frame, relocates the target element, and continues executing the task without a single line of code breaking. Let's look at how this system operates in a high-value business scenario. Automated competitor inventory tracking and procurement routing. For an agency or e-commerce operator, logging into a dozen different distributor portals every morning to manually check stock fluctuations and update local data tables is a massive time sink. We automate this entire logistics workflow by configuring an autonomous browser agent loop. You give the system a high-level goal in natural language. Log into our supplier portal, navigate to the enterprise network hardware catalog, find the current pricing for all items matching switch 24 port, and save the matrix into our database. The browser engine opens the page, inputs the security credentials into the detected fields, navigates the nested category menus, handles paginated search results, and parses the layout. It executes the entire operation seamlessly, bypassing the need for an expensive, dedicated engineering team to write custom API code for every vendor platform. Phase 1. Task initialization. Establish your core prompt parameters inside the agent workspace. Input the target starting URL, any required user credentials, and an explicit description of the final data payload you want the agent to retrieve. Phase 2. Visual mapping run. Skyvern initializes a headless Chromium browser instance, loads the page, and maps out the visual grid. It assigns unique numerical identifiers to every button, link, and entry form found on the screen. Phase 3. Cognitive action routing. The coordinate map and visual state are passed into Claude. The model determines the single best next action required to fulfill the goal, selects the corresponding element ID, and commands the mouse to click or type. Phase 4. Extraction and storage. Once the agent navigates to the final destination page, it reads the target data block, formats the findings into a structured layout, terminates the browser session cleanly, and dumps the payload into your local workspace. The anti-fragility principle. Traditional scrapers crash when encountering unexpected pop-ups, cookie consent banners, or promotional modals. Claude instantly recognizes these visual interruptions as obstacles, identifies the close button, clicks it, and immediately returns to the primary task layout. When you evaluate operational capacity based on adaptability, setup complexity, and system resilience, traditional automation models become entirely obsolete. Traditional web scraping is essentially a fragile house of cards. The second a target website updates its layout, edits a CSS class, or moves a checkout button 3 pixels to the left, your entire automation pipeline crashes. When you compare legacy macros to a vision-based agent stack, the old way of interacting with the web becomes completely indefensible. By shifting to this adaptive architecture, you drop setup times from days of custom code down to a simple 90-second natural language instruction. Because the model navigates using real-time computer vision instead of hard-coded back-end paths, it natively handles complex forms and layout changes while cutting your engineering maintenance overhead to near zero. Because the system relies on real-time visual analysis rather than hard-coded scripts, it doesn't care if a website changes its design or structure. If a layout updates, Claude simply scans the fresh visual frame, relocates the target element, and continues executing the task without a single line of code breaking. The defining reality of scaling a modern business infrastructure is that relying on rigid, blind automation macros or paying human virtual assistants to perform repetitive clicking tasks is a permanent bottleneck to your leverage. Continuing to build fragile, code-heavy scraping scripts when you could be directing an autonomous, vision-powered browser agent is a massive drain on your operational execution speed. Your technical challenge for the next 24 hours is to isolate the most tedious, repetitive multi-step workflow you currently perform inside a web browser. Download the open-source Skyvern repository, link it to Claude's model endpoint in your configuration settings, and execute your very first automated visual text navigation loop. If you are ready to move past fragile scripts and want immediate access to the pre-configured workflow setups, terminal initialization commands, and advanced agent prompt templates that allow you to deploy a fully autonomous digital assistant network, the complete master architecture files are waiting for you in the description down below. Make sure to hit that subscribe button because in our upcoming system breakdown, we are revealing how to hook this visual browsing agent directly into an automated document parsing pipeline that downloads, reads, and categorizes corporate expense receipts entirely on autopilot. See you in the next one.